Hello, everyone, and welcome to today's class. I'm really glad you're here. Now, I know that for a lot of us, math can sometimes feel, well, a little bit overwhelming. But I promise you, today we are going to make it completely stress-free and honestly, a lot of fun. We're diving into a topic called mensuration. I know, it sounds like a big, intimidating word, but it literally just means measuring the shapes that make up the world around us. So, grab your notebooks, take a deep breath, and let's get ready to learn. So, here is our game plan for today. We'll start by figuring out what mensuration actually is. Then we'll look at perimeter, which is all about boundaries, followed by area, which is the inside space. After that, we'll tackle some real-life problems together, and finally, we'll wrap up with circles and beyond. Let's jump right in. All right, section 1. What exactly is mensuration? Well, mensuration is simply the math of measuring geometric figures. We're talking about their lengths, their surfaces, and their spaces. But before we get bogged down in formal definitions, I want you to use your intuition for a second. Imagine you have a beautiful, empty dirt park. If you want to build a wooden fence all the way around the outside of this park to keep stray animals out, and then you want to plant soft green grass all over the ground inside, which one of those tasks represents the perimeter, and which one represents the area? Just think about that for a second. Did you figure it out? Putting up that fence, that is your perimeter. It's the outer boundary, the edge. And because it's just a line, we measure it in simple, one-dimensional units like centimeters or meters. On the flip side, planting the grass is the area. That's the enclosed surface inside the boundary. Because it covers a flat, two-dimensional space, we have to measure area in square units like square centimeters or square meters. Honestly, drawing this hard line in your mind right now will save you so much confusion later on. Moving right along to section 2, perimeter, or as I like to call it, walking the edge. The absolute simplest way to define perimeter is that it's the total length of the outer boundary of any closed shape. I want you to imagine you are standing right at the corner of a park. Let's call that point A. If you walk along the edge of the park, tracing the entire boundary, step by step, until you arrive exactly back at point A, the total distance you just walked is the perimeter. You are literally just adding up the lengths of all the sides. That's it. Now, looking at this, you might be feeling a tiny bit of math anxiety creeping in. I know, seeing all these letters and numbers on a formula sheet can be intimidating, but listen to me, you do not need to blindly memorize these. We are going to understand the logic behind them together. And once you get the logic, I promise you, you won't forget them. Let's think about a rectangle. A rectangle has 2 equal lengths and 2 equal breadths, right? So if we walk the boundary, we add the length plus the breadth plus the other length plus the other breadth. That gives us 2 lengths and 2 breadths in total. If we just pull that number 2 outside the brackets as a common factor, we get our magic formula 2 multiplied by length plus breadth. See, it's not some random confusing rule. It's just a handy shortcut for adding up those 4 sides. Okay, I'm gonna let you in on a little teacher's cheat code. Whenever you see the word regular in front of a shape, it means all of its sides are perfectly equal. And for these regular shapes, you don't even need to add. You just multiply. A square has 4 equal sides, so the perimeter is just 4 times the side length. A regular pentagon has 5 sides, so it's 5 times the side. A regular hexagon, you guessed it, 6 times the side. It really is that easy. All right, section 3. Let's talk about area, the inside space. Area is simply the amount of surface that is enclosed by that boundary we were just walking. So if perimeter is like drawing the outline of a shape with a pen, area is when you take a big, thick marker and color in the entire inside space completely. Or, going back to our park analogy, it's the amount of dirt you need to cover with grass, or maybe the floor you need to cover with tiles. So how do we actually calculate this space? Well, for a rectangle, the area is simply the length multiplied by the breadth. But here is where you have to be super, super careful. When you multiply a length in meters by a breadth in meters, your answer isn't just meters anymore. It becomes square meters. So the absolute most crucial point here is to always remember your square units when calculating area. If you forget them, you'll lose points on your test, and we definitely don't want that. And what about our friend the square? Well, a square is really just a special type of rectangle, where the length and the breadth happen to be the exact same number. So instead of saying length times breadth, we just say side times side. For instance, if a square has a side of 60 centimeters, the area is 60 times 60, which gives us 3,600 square centimeters. Make sense? Okay, let's put this into practice with section 4, solving real-life problems. I know word problems can make people panic, but they are honestly just fun little puzzles waiting to be solved. Here is my foolproof, 4-step cheat code for solving any mensuration word problem without a drop of stress. Step 1. Ask yourself, are they talking about the boundary, like a fence, or the surface, like a carpet? Step 2. Pick your perimeter or area formula based on your answer to step 1. Step 3. Check the units. Are they all the same? If one is in meters and one is in centimeters, you have to convert them to match. And finally, step 4. Multiply your final answer by the cost rate given in the problem. Let's try one out together. Here is a great problem. We need to find the cost of fencing a rectangular park that is 250 meters long and 175 meters wide, at a rate of 12 rupees per meter. Okay, step 1. Fencing means outer boundary, so we know we need the perimeter. Step 2. Our formula is 2 times length plus breadth. That's 2 times 250 plus 175, which is 2 times 425, giving us 850 meters. Step 3. Units are all in meters, so we're good there. Step 4. Multiply by the cost. 850 meters times 12 rupees per meter gives us a grand total of 10,200 rupees. See? Absolute piece of cake. Now let's flip it and look at an area problem. What is the cost of tiling a plot that is 500 meters long and 200 meters wide at a rate of 8 rupees per 100 square meters? Step 1. Tiling means covering the surface, so we need area. Step 2. Length times breadth. 500 times 200 is 100,000 square meters. Step 3. Units match perfectly. Step 4. Cost. But wait. Look closely. The rate is 8 rupees per 100 square meters. So we have to take our 100,000, divide it by 100 first, and then multiply by 8. That gives us our final answer of 8,000 rupees. You guys are doing a great job following along. Finally, let's look at section 5, circles and beyond. You guys have been absolutely fantastic today, so let's wrap things up with round shapes. When it comes to a circle, the outer boundary isn't called a perimeter anymore. It gets a special VIP name, the circumference. To find the circumference, we use a slightly different formula, 2 times pi times r. The r stands for the radius, which is just the distance from the very center of the circle to the outside edge. And that funny little symbol, pi, it's just a constant mathematical value, usually written as 22/7 or 3.14. It's basically the secret key to unlocking all circular measurements. You have worked so incredibly hard today, and I am super proud of how well you've grasped these concepts. We have totally mastered 1D lines and 2D surfaces. But before we go, I want to leave you with a little brain teaser. Imagine if our flat, grassy park suddenly turns into a deep 3-dimensional swimming pool. How on earth will we measure the water inside it? Well, that introduces a whole new dimension called volume, and that is going to be our adventure for the very next class. Keep practicing those formulas, stay curious, and I will see you next time.